Hi, this is Mrs. Thompson. We're looking at adding integers today. When we start adding integers, some of our North Dakota learning targets that we've looked at in the past have been here, but now with some of our Common Core, I haven't posted those yet, but I will be looking at adding those in. In your notes, you had opposites the other day. I would like you to also add to opposites additive inverse. It means the exact same thing as the opposite. So if we think of the additive inverse, 2, the additive inverse is going to be negative 2. If I ask you for the additive inverse of negative 3, the additive inverse would be positive 3. We are going to be looking at using what's called the number line model. And it says to add integers, you start at the first addend, which in this case would be 5, negative 6, and negative 4. Then you move the number line in the indicated direction. Now, if the second number is positive, we're going to move to the right. If the second number is negative, we're going to move to the left. So a positive tells us to move to the right, a negative tells us to move to the left. In this case, we're going to start at 0 and have 0 on our number line. Where is positive 5? We're going to start at a positive 5. And then since it's negative 8, we need to move 8 units to the left. 8 units to the left takes us to negative 3. If we have negative 6 plus 10, where is negative 6? Well, we're going to start at negative 6. It's to the left of 0. Here's negative 3, negative 4, negative 5, negative 6. And we are adding 10, which means we want to move 10 units to the right. Here's our 5. So if at negative 6, we're going to move 10 units. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where do we end up? 4. Our solution here was negative 3. Our solution here is a positive 4. Negative 4 is our start point in the last one. So we're going to start at negative 4. When you start at negative 4, we are then going to add negative 3. Negative tells us go to the left. So we're going to go to the left 3, which means we're going to go down 1, 2, 3. From 4, 1, 2, 3 takes us to negative 5, negative 6, negative 7 for our solution. I would like you right now in your guided practice to take a look at these 4 questions, negative 1 plus 3, 1 plus negative 4, negative 3 plus negative 2, and negative 2 plus 2, and draw each one on the line, and then also tell me what was each one equal to. Now, I know some of you could do these in your head. The other thing we're going to be talking about is this key concept. Last year, I know you did some addition with integers, and the key thing is that if you have the same signs, you add the absolute values. Use the common sign. What does that mean for you in terms of when you're filling in your notes? And this is really on the bottom of page 4. What it means is that if you have a positive number plus a positive number, your answer will always be a larger positive number. This is what you've been doing since about 1st or 2nd grade. When we talk about a negative number, same sign plus a negative number, we are going to end up with our answer also being a negative number. What about if we have different signs? It says subtract the lesser absolute value. That's why we had to talk about absolute value the first day. Absolute value, remember, is that distance from 0. Subtract the lesser absolute value from the greater. Use the sign of the number with the greater absolute value. We're going to do some examples with this, but if you take a look at this number, what that means is if we have something like negative 7 plus 10, well, we take the larger absolute value, which is actually, this is what we want to think in our head. So this is our thinking that we're doing. We're thinking 10 minus 7. 10 minus 7 is equal to 3. Since 10 was a larger and it was positive, our answer is positive 3. What about if we would have had 3 plus a negative 10? Well, here we would be thinking in our head, think, 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 if you want to think of Winnie the Pooh, 10 minus 3. 10 minus 3 gives us 7. But here, our larger absolute value was 10, and it's negative, so our answer to the problem is going to be negative 7. So if you turn to your packet right now on page 2, we're going to fill in some properties. What properties am I talking about? The first one is called the additive identity property. So this is on the second page of your notes. And right now we're only going to be looking at addition, but later we'll be doing the multiplication part. You're going to fill in the sum of an integer and its and 0 is equal to that integer. That means if I take 3 plus 0, I get 3. If I take negative 7 plus 0, I get what I started with, negative 7. That's called the identity property. 0 is actually the identity in addition. 0 is the identity. And what the identity means, if you think of that when you look at the mirror in the mirror, it's looking exactly the same as what you started with. The next thing, so additive identity is 0 as you're filling in your notes. This is how they write it algebraically. A plus 0 equals A. I don't know if that helps you or not to put in your notes. That's up to you. The next property a little further down is you're going to see the inverse property of addition. I think we put additive inverse property. It means, in words that you should write out, the sum of any number and its additive inverse or opposite is always equal to 0. Is the same kind of as an equal. Equals 0. So 5 plus negative 5 is 0. A plus negative A is 0. Now, the put together method is kind of the rules for our integers that you're working with, and that's what we just talked about. To add two integers, you're going to put them together. So I'm going to have you take a look at these guided practice. 28 plus negative 12. First thing we have to decide, are the signs the same sign, or are we working with different signs? And in this case, they're the same. So this is where we were talking about positive. I'm going to put that in a parenthesis and write it out, instead of writing out the word positive, plus another positive equals a positive. A negative plus a negative is going to be equal to a negative. When the signs are different, remember that's when you have to be thinking of finding the difference or subtracting. Here the signs are the same. Our answer is going to be negative. 28 and 12. I'm going to add 28 plus 12. 28 plus 12 gives us 40. Our answer is negative 40. 19 plus 0, and then I believe this should have been in here, a plus negative 7. Well, 19 plus 0 is still 19. Plus a negative 7. Signs are opposite. Need to subtract. 19 is the larger, so we keep the sign of the larger absolute value, which means this is going to be a positive answer. 19 minus 7 gives us positive 12. Now usually you don't have to put the plus in front, you're just going to put 12. Negative 3 plus negative 9 plus 3. Now you could do this in order, or you could use what's called our commutative property and think, oh, I know, negative 3 plus 3, and switch the order. Negative 3 plus 3, what property are we talking about? We just had it, so take a look back if you're not sure. Negative 3 plus 3 gives us 0, and then we're going to add a negative 9. Well, 0 plus negative 9, this is our identity property, gives us negative 9. Negative 8 plus 7 plus negative 2. Now, you can use a commutative property and switch the order, or you can do it in order. Negative 8 plus 7. Signs are opposite, subtract. It's going to be negative 1. Plus negative 2. Negative 1 plus negative 2, signs are the same. I'm going to add them. I get negative 3 for my solution. What if you have more than one group when you're working with addition in a problem something like this? Just like that last one, you might decide to add the negative 56 and negative 164. They're both negative. We're going to keep it negative. 56 and negative 164. If we're adding those together, and for some of you, especially if you don't have your calculator, you might be thinking, okay, I'm going to add these together. 6 plus 4 gives us the 10. Carry the 1. 6 and 5 is 11, gives us 1. That's going to give us 12. And we are talking about a negative 220. Now, sometimes you can do that in your head. Sometimes you might use that addition model. When I look at this problem, I might be thinking in my head, okay, I could add the two negative numbers together, but I think it's actually easier to add negative 62 and 76. Why? I'm subtracting them. So 76 minus 62 gives us 14. And it's going to be positive because 76 was larger and it was positive. Now I have negative 39 and 14. In my head, I'm thinking Negative 39 has to give me 39 minus 14. Well, 39 minus 14 gives me 25, and my answer in this case would be a negative 25. Why negative? Negative 39 was larger. In the next page of your notes, as you look at the top of page number 5, you're going to see subtracting integers. This is also back on the first page, subtracting integers. As you look at subtracting integers, what it means to subtract is to add the opposite. So anytime you're asked to subtract integers, you're really going to be adding the opposite. So here's how you want to think of it. 2 minus 9. 2 plus a negative 9. 2 plus negative 9. The signs are opposite. We use our rules from addition. Subtract. Keep the larger absolute value. 9 minus 2, negative 7. What about if you have minus a negative? Well, that means 4 plus the opposite of negative 5. Well, what's the opposite of negative 5? The opposite of negative 5 is 5. 4 plus 5 gives us 9. Now, they wrote it out algebraically. Sometimes I think that might be a little more confusing than helpful. Key thing, remember, change minus to always adding the opposite of whatever follows it. We're going to do a few examples. I'm not sure if in tomorrow's homework we're going to stop at addition or if we'll do addition and subtraction. We'll kind of see how class goes. As we rewrite it, you want to be thinking in your head, what do I have to do to solve this problem? Well, I'm going to first rewrite it. In your homework, I want to see all of these rewritten. Negative 8 plus negative 4. Signs are the same. We should be adding. Negative 12. Keep the same sign. Next problem. Negative 12. Someone said, why do they put the parenthesis around it? Well, a lot of times, especially to separate minus and negative. Plus, what is the opposite? That's what has to go next after our addition. The opposite of negative 10. Well, what the opposite of negative 10 is positive 10. So we would put that as negative 12 plus 10. Negative 12 plus 10. Signs are opposite. What do we do when signs are opposite? Signs are opposite. We actually want to subtract 2. But we have to keep the sign of the larger number. Keeping the sign of our larger number means we want to keep the negative sign. Our answer would be negative 2. 12 minus 15. 12 plus negative 15. Signs are opposite, just like the problem above. Larger number is negative. Our answer will be negative. 15 minus 12 is 3. Next problem. Negative 8. Never change the first number. It's always changing subtraction to addition, followed by the opposite. The opposite, this case, of negative 8 is positive 8. What property is that when we add negative 8 plus positive 8? Gives us the identity 0. And the property, anyone think of the property? That property is called our additive inverse, if you remember that from earlier. Additive inverse. 2 more examples, 3 more examples, excuse me, and then you are on your own. You should have this completed when you come into class. So negative 2 this time, plus 5, the opposite of negative 5. Answer should be 3. Signs were opposite, you subtracted. Try these last 2, maybe pause it and try the last 2 in your notes, and then I'm going to continue. 5 plus 5, you know that one. The last one, 10 minus 3, 7. The worksheet we're going to be looking at is the sum up. Thanks.